Hey everyone, you know what I'm going to say. Professor Michael Scanlan here. Thanks for joining. I want to talk about magnets today. You're like, Professor Scanlan, we've done that already, right? We did the magnets thing. Yeah. Oh, if you only knew how little we've actually scratched the surface of magnetism. And that's what we're here to talk about today. A little bit more of magnets. Now, what is this? I hope you said it's a compass, because that's exactly what it is. We're going to make a compass today. But before I do that, I want to talk a little bit about how this works. A compass is a very thin piece of metal that is pivoted about a central axis, okay, and allowed to swing freely. Now these were and still are to a degree used in navigation because a compass points in what direction? North. More on that in a second. Not every material is magnetic. We tend to think of metals as magnetic, but not all metals are magnetic. One of the things you're commonly associating with magnetism is known as a ferromagnetic material. It's going to be mostly iron-based, okay? And so I have a needle here. I know you probably can't see it on camera, but it's a sewing needle. It's metal. It's mostly iron. Inside this piece of iron, there are atoms and electrons. They're bonded in such a way that small groups of electrons, small groups of atoms and their electrons, the electrons move in similar fashion. When an electron moves, it creates what we call a magnetic field. What do you mean, this is a magnet? Not right now. Little bitty sections of it are magnets. But those sections called domains cancel one another out on the whole. And so I get just a regular old piece of iron. But if I magnetize a piece of iron, I create, or I induce magnetic properties on that piece, and it becomes a magnet. So, I have a magnet, okay? To do this, you're going to need a needle, a magnet, something light to float on, okay? I've got a container here with water, and I've got some tape behind me. So first, I'm going to take the needle, and I'm going to rub it, if I can, about 30 times in the same direction. If I look at this, my compass is pointing north, being that way, kind of towards the water. And that's fantastic. Now, the magnetic poles on a compass, or on any magnet, are labeled north and south. And there's a good reason for that. The north side of the magnet points to the north. Now, think about that. The north side of the magnet points to the north. What do we know about magnets? We know that opposites attract and likes repel, don't we? So in other words, the north side of that compass is pointing to a south magnetic pole. So what does that tell you about Earth's magnetic field? That it's backwards in what you think it is. The magnetic pole in our northern hemisphere is actually a south magnetic pole, and the magnetic pole in our southern hemisphere is actually a north magnetic pole. Isn't that weird? It gets weirder than that. These poles over time have actually changed places. Ah, you see, it's aligning. Even though it's lopsided and in the water, it is aligning. Sorry, I'm gonna try to get this to change its exposure. It is aligning with north. So this side of my needle is the north pole of the magnet, and this side is the south pole, and I think it just demagnetized. Anyway, the Earth's magnetic field is backwards from what you think it is, as I said, but it gets stranger than that. The Earth's magnetic field has flipped polarity over time. We're not really sure why. It's pretty cool though. So with my compass, okay, you can see if rubbing the needle more gives you a longer lasting effect. Try floating in an oil, maybe that works a little bit better. Get a marker and color one end, color the end that points north or south so that you know which end is which. And you have just made a small magnet that can then be used to point to north. Now the thing about there's a lot of things about our magnetic field. The thing about Earth's magnetic field is that the magnetic pole in the northern hemisphere, which we just found out is actually a south pole magnet, is not aligned with our geographic pole. Okay, so it's offset. So this compass doesn't point to what we call true north. The south magnetic pole, or the magnetic pole in the southern hemisphere, is actually off the coast of Antarctica. It's not even close to our geographic south pole. Our poles move, the magnetic poles. So it's really weird. You could spend all day on it, but I know you don't have all day. I'll see you in the next video. Stay safe, stay sane, and stay safe, everyone. Thanks for watching.